This broom is in a state of equilibrium, which means that the sum of the forces on the broom equals 0, and the sum of the torques about any axis is equal to 0. So the weight of the broom should be equal to the normal force, which is exerted on the broom by my hand. And the sum of the torques about any axis, okay, let's choose my hand as the axis, should equal to 0. So that means that the torque that this side of the broom exerts should be equal to the torque that this side of the broom exerts about this axis. And of course, the torques are oppositely directed. One is positive and one is negative. When you add them up, you should get 0 for equilibrium. So which end weighs more? Does this end weigh more, or does this end weigh more? Well, wouldn't this end have to weigh more? Because you'll notice that its center of mass, which would be about right here, is pretty close to the fulcrum. Whereas the center of mass of this end of the broom, which would be about right here, is pretty far away from the fulcrum. So wouldn't this have to weigh less than this end here? Now we can check this by cutting this in half. Okay, actually cutting right here. So separating this end of the broom from the handle and then weighing each part. So this end of the broom has a mass of 224 grams. If you want to figure out its weight, you would have to first convert that into kilograms. So that would be 0.224 kilograms. And if you wanted to figure out its weight, you would multiply that by 10 meters per second squared. So we would have about 2.24 newtons. Now let's take a look at this end of the broom. And you can clearly see that this end of the broom weighs a lot more.